Now, chapter 11 is about the system of linear equations 2 by 2 and 3 by 3. So in this chapter, we are going to learn how to solve these type of equations with two unknowns. We know it, with three unknowns mainly. We are going to learn here by using technology and without technology also. So our aim is at the end of this chapter to be able to solve these type of question without technology. Of course, with technology it's easy. I will show it. So to learn it, first we are going to do in part A and B, we are going to analyze the linear equation. We are going to just see some points about the equation which we didn't think about before. Then in part C, in our part A, B also we are going to learn this new method, how to solve them by using this method, and we are going to practice it in part C by 2 by 2 equations. So don't tell me why we need to solve 2 by 2 equation. We are going to practice this method in 2 by 2. Then at the final, at part D, we are going to implement this method to 3 by 3 simultaneous equations. Let's get started. Let's start with some definitions. System of linear equations. So linear equation is a linear one with many unknowns and coefficients, which has a result, and what we call the solution for the x's, which gives correct result for my equation. We call it solution, right? So there is also some definitions: inconsistency and consistency. Inconsistent means when you have simultaneous equations, let's say 2x plus y equals to 5 and y plus 2x equals to 3, for example. If I have these simultaneous equations, here there is an inconsistency. How we can understand? For example, for the first one, if for x 1 and y 3, if I have correct result for the first one, but the same solution does not give me in the second one. If I have this case, it means there is an inconsistency in my simultaneous equations. So this solution works for the first one, but it doesn't work for the second one. Consistent if there is at least one solution. So there is also one more definition: underspecified and overspecified. For example, when you have 2x plus, okay, let me go with the same one, and let's say 3x minus y equals to 10, and let me go 4x plus 10y equals to minus 1. For example, if I have this simultaneous equation, look at here, I have two unknowns and three equations. This one is overspecified. In order to solve it, I just need only two equations, but they give me one more, which is overspecified. But if they give, for example, this one with two unknowns, one equation, let's say 10, it's underspecified. I cannot solve exactly the solution for underspecified equations because I need one more equation. So when you have more equation than unknowns, it's overspecified. When you have less equation than unknowns, you have underspecified linear equations. Just definitions, you will have practice in that exercise. Now, echelon form, it's not echelon form for this one. In the matrix, we call it augmented matrix. What's augmented matrix? Just we convert this simultaneous equation into the coefficients. You will see later that to solve this linear equation, system of equation, we only need their coefficients. So to write their coefficient, we'll just make a matrix, okay? On the right-hand side, we'll just write their results, and on the left-hand side, we'll just write their coefficients. For example, just quick example, let's have again these simultaneous equations equals to 5 and 3x minus 4 equals to 10. If I want to write an augmented matrix, I will just take their coefficients. On the first one, it's 2, 1, 5, and 3, minus 4, and 10. On the right hand side, you have only results. And here, just pay attention. If you go with the first x, there should be also x here. Just write their coefficients. Okay. For example, let's go with analyzing some linear equations. If I ask you, for example, this type of question, 2x minus 3 equals to 4. So we know it's easy to solve, right? There is one equation, one unknown, so we know how to solve it. It will be 7, so x will be 7 by 2. But if, for example, if I change it, let's say 2x minus 3y equals to 10. So what will be the results here? Here I have underspecified equations. So for this case, actually I have infinitely many solutions, right? So if I just say randomly x equals to 1. So for x, I can find what y is. What will be y? Y will be minus 8 by 3. If x equals to 2, let's say, y will be 6 minus 2. So infinitely many solutions for this one. Here we can write generally the solution. The solution will be if x equals to t or y equals to t, then if one of them is independent, the other will be dependent. Y will be 10 minus 2t divided by minus 3. Okay, here for t any real number, we write it generally. So one of the unknown will be independent, the other one will be dependent. If we have, for example, let's say with 3 unknowns in one equation, let's say, for example, 3x plus y minus 4z equals to 10. For example, if I have 3 unknowns, 2 of them will be independent to change, the other one will be dependent. For example, if I call x equals to t, and let's say z equals to s, for any t and s are real numbers. So from here, what will be y? So I just call them random, so any of them can be independent to change. So the y will be what? 10 plus 4c minus 3t. So that's it. It doesn't have coefficient. If it had coefficient, we would divide it. So what did I do? Just instead of z, I put s, and instead of x, I put t, then write in one line. I took them all to the right, then I have my y. So my solution will be x equals to t, z equals to s, and y will be 10 plus 4s minus 3t for any t and s, all real numbers.